Hello, college algebra. This screencast is primarily meant for the kids who left for band. It's essentially what you missed when you left today, uh, but also it might be good for those of you to just to watch and review if you were in class. So we're talking. We moved on to section 3.4. We're going to hit a little bit of what we're talking about today on Friday, but mostly we're going to move on to the next part, which would be radical equations. So looking at solving rational equations, and there's two processes, and really you want to be able to do both, to do two different types, and this is when we're solving using cross multiplication. All right, so if you have, for example, a divided by 3 equals 7 divided by 10. We multiply across. You guys have all made that x before, so a times 10 is 10a. 3 times 7 is 21, so a is going to be 21 over 10. All right, this is cross multiplication where we go across. Basically, anytime you have a fraction equals a fraction, you're going to want to do cross multiplication. All right. These things can be a little bit more, they can be much more complex. For example, if we have 8 divided by x minus 1 equals 5 divided by 2x plus 3, we have a fraction equals a fraction, so we're going to multiply across and then just solve that from there. So 8 times 2x plus 3, well, 8 times 2x is 16x. 8 times 3 is plus 24. That is equal to 5 times x minus 1, so 5x minus 5. All right, and now we would solve from there. We'd subtract 5x from both sides. Probably subtract 24 over to this side. We'd get x is 29, so that's going to be negative 29 over 11. So that's cross multiplying, and that is nice to do in some other instances. Like here's another just example where let's say we have 1 over x plus 5 over 2 equals 6 over 9, let's say. In this case, it might not be too bad for us to actually add these two fractions, 1 over x. You need to find a common denominator, so 1 over x plus 5 over 2. You need to find a common denominator. So if I multiply this by 2 and by 2, and this by x and by x, now I can add them. I've got 2 plus 5x. That's all going to be over 2x. Okay, this equals 6 over 9, which now I can cross multiply, and then I would solve similar here. I cross multiply because I have a fraction equals a fraction. Okay, so in a situation like this, it's not too bad just to add the fractions and then cross multiply. But when we get a little bit more complex, I tend to think it's easier to use our second process. Okay, and our second process is using a common multiple. So process 2 would just be using a common multiple. So kind of a pretty basic example would be the same one we just looked at, solving 1 over x plus 5 halves equals 6 over 9. And we usually start just by writing down what a common multiple of all these denominators would be. Okay? This is a kind of a slick method that allows us to remove our denominators before we start to do any adding, subtracting, really any algebra besides multiplication. What we do is we end up multiplying both sides of the equation by the same thing, because it has to be the same when we multiply here and here. but it's a common multiple of all of these denominators. So if we think about the numerical aspect, 2 and 9 both go into 18. Here's a 1 in front of this x, right? So 1, 2, and 9 all go into the number 18. So that's a common multiple for them. And we have an x here. We have no x there, right? So a common multiple would be 18x. And if you're thinking about, well, how did I come up with that? Well, we look at these three denominators and we say, well, I can make this 9 and 18x if I multiply by 2x. I can make this 2 and 18x easily if I multiply by 9x. I can make this x and 18x if I just multiply by 18. So that's how we think of it. All right. What we're actually going to do is we're going to take this common multiple, and I'll just rewrite here to get a little space. But we're going to take this common multiple, and it multiplies both sides of the equation. All right. Remember, when we multiply fractions, it's like saying 18 over 1. This just goes to each of our numerators, and the rest of it, we don't worry about our denominators. The denominators will not change in this process. Well, we have to distribute 18x through here, so we get 18x times 1. That's just 18x divided by x. When we take 18x times 5 halves, that's plus 5 times 18x all over 2. And that is equal to 6 times 18x on the other side, all over 9. All right? Now, this is a step that we tend, and the more you do this, you kind of skip this step sometimes. Like, when we see what happens when we simplify here, 18x over x is just 18. Right? Our denominators disappear here. So, if I'm multiplying this, and I know I have 18x times 1 divided by x, that's just going to be 18. Like, the more practice we get, the easier it is to skip this step. So, that's plus 5 times 18x. Well, 18 over 2 is what? 9. So, this really is 9. 5 times 9x is just 45x. Right? Or you could actually take 5 times 18 divided by 2. It's going to be 5 times 18 is 90, divided by 2 is 45. That's where we get that number. And then 6 times 18x divided by 9. Again, 18 divided by 9 is 2, so 6 times 2 is 12x. And now we're solving this equation this way. All right. You can say 18 is equal to negative 33x. So then x is going to be negative 18 over 33. All right. So a fairly basic example using the common multiple and how we can just reduce and remove all these denominators from our fractions. Okay? I do want to look at a more complicated example using this second process. We'll actually talk about this more in Friday's class because we didn't quite finish today before the bell hit us. But if we have to solve 6 divided by y plus 3 plus 2 divided by y equals 5y minus 3 over y squared minus 9. We can solve this using both methods. Either process 1, which would be finding or using cross multiplication. So we added these two fractions. Then we could cross multiply. But because this is a pretty complicated expression, we don't necessarily want to do that all the time. It's going to be a little bit simpler, for my money anyway, to use this least common multiple method. So the first thing with all these problems is to look for little hints and little things that we can use And so right away, I'm just rewriting this because I noticed that y squared minus 9 is a difference of squares. That's y plus 3 times y minus 3. And now when I try to find my common multiple, I look at all these denominators and I'm basically saying what is in here that is not in this one, or that is not in this one. Because my goal is going to be, after I multiply both sides, my goal is to try to cancel all of these out. So I need to multiply by them. So I have a y plus 3 in this denominator. So in my multiple that I am going to multiply through, I need a y plus 3. There's a y in this denominator. I need to cancel a y when I multiply it through, so I need a y. I already have this y plus 3, so it's going to cancel this y plus 3. But I need a y minus 3. So I add that into my common multiple. All right. So this is actually what I'm going to multiply both sides of this equation by. Y plus 3 times y minus 3. You can order that any way you want. All right, so we're going to take this there. We're going to take this there into there. All right. So just when I multiply this first piece, I'm going to take all this divided by y plus 3. So what will cancel from this numerator? The y plus 3's will cancel. So 6 times what's left is y times y minus 3. Okay, my entire denominator is gone. It just canceled out. This y plus 3 divided by y plus 3 is 1. Taking this term into my 2 divided by y. What's going to cancel? The y over y will cancel. So plus 2 times y plus 3 times y minus 3. And then on this side of the equal sign, I have a y plus 3 that will cancel, and the y minus 3 will cancel. Okay? So I'm left here with 5y minus 3 times the only piece of this multiple that's left is y. Right. So again, it might take some practice. So you might need to rewrite this step like we did here on this problem, where you actually write out what you're going to get: 18x times 1, 18x times 5, 18x times 6, and then you can divide them out from there. But on a problem like this, that's pretty long, so in a perfect scenario, you're actually going to be canceling kind of on the fly here. All right? 6x squared minus 18y. For simplifying, we still need to solve for y. We'll end up distributing this back. This gets me 2 times y squared minus 9. This is equal to 5y squared minus 3y. All right. And now 6y squared minus 18y plus 2y squared minus 18 equals 5y squared minus 3y. So from here, we need to just solve this quadratic equation. It needs to equal 0. All right, so we're going to combine all like terms. So I have a 6y squared plus 2y squared, that's 8y squared, minus 18y minus 18 is equal to 5y squared minus 3y. Moving my 5y squared over, I'm left with 3y squared. On this side, moving this over, I'm left with minus 15y. And that's equal to negative 18. All right. From here, we can factor and solve. All right. We're going to pick up tomorrow right about here, or on Friday.